Good morning. Can you hear me? Yes. Can you hear me? Okay, good. So yeah, the question, the title is Beyond the Hype. In a way, it's similar to RAM in a sense that it really goes from the practice. It goes from the doing a multiple projects, multiple industries, and learning what is the difference between what we are usually served by the media and what is really actually done and how to do it. So you know, I have a story to tell. So you know about Sophie, the robot that's going to replace us, and we all know this is like completely not going to happen. But what's happening is that it influences a lot of people to think that we know how to do technical things that we don't have a clue how to do it. So last summer I was traveling from Vienna to Berlin, and I got a call from a friend that's saying like, oh, I heard you're doing something with artificial intelligence. I have an excellent idea, a project like the best ever. And I said, yeah, sure, I'm interested, like, what's it about? So he said, like, I need somebody to build me an AI, and the AI should read 10 books that I tell them, and just distill this knowledge and write another one. And this is going to be a bestseller, I'm promising you. And of course, I was like, I don't even know where to start to explain to you how far away it is. And for this hype, we are also a little bit partially to blame ourselves. So one of the experiments that we did, like last year, for fun of it, of course, natural language processing, we did Kafana bot. We feed it with 30 megabytes of Kafana songs, which is like really interesting kinds of lyrics for you don't know what it is, and make it just to generate this kind of garbage. It looks real because the input is exactly the same. So it's a song about I'm early morning at here, and it's just a typical lyric. So I'm trying to get right now to the beginning, to the roots, and see what we can actually do, and how to actually use it in a business settings, how to solve the actual problems, how to make money, how to build companies, how to do something. And I'm gonna apologize for all the technical people right now, but for untechnical people, what we call AI today. AI is, we build AI since God knows when. When we talk about AI today, most people think about systems that are built using this technique called deep learning. And that deep learning is very easily illustrated with these pictures. What we do today, which we don't know how to do it, we use something called neural networks, which we know for some time, but what we have now is enough data, enough processing power to make it like really deep. And deep means there are a lot of layers. And when we do this, if we do an input, like pictures like this of the faces, they have some kind of emotions, and we know what the emotions are at the end. What's going to happen by some kind of magic, which is not completely understood today, the network will self-organize. And we're going to specialize different layers, different neurons to do different things. One will decide to do the edge detection, some will decide in the middle to look for the noses and eyes, the layers afterwards will construct the faces. At the end, you will get the answer, is this person smiling or not? And if you try to build systems like that, just using the standard engineering tools, like writing the code, nobody knows where to start. Today, this is one of the exercises that we do at the lectures. Like when you do machine learning course, after a few lectures, you do it as an exercise. And this is extremely powerful method, and we really start pushing it everywhere, and it really works very well in many, many cases, but not for all of them. One of the things that is also that is always very, very important is really to find a good business case where we can apply what we know today. One of the good example, for example, is visual processing. It's considered kind of the soul thing. We can not just classify what is in the pictures, we can really easily just reuse models that exist and really like tell you pixel perfect, is this a bicycle or a man or elephant or cat or whatever. And these things work very well. This is a system done by Facebook, but there are many others, they're all very, very well. Models are good today. But what is important is to find a good business case. And I'm going to show you one thing that we're working on with a partner from Sweden. It's a Swedish telecom, Swedish startup that is working with satellite imaging. The people came from the European Space Agency. They really know satellites. They know how to clean the pictures, connect all the layers together. And the good project with them is they find a good business case for that. So what is inside here, this little green square, it's a solar panels. And why is that important? It's not technically that difficult. If you know a little bit about deep learning and image processing, it's not that difficult to find solar panels on the roofs of the houses. But why is that important? It's a very simple thing. So let's say all those people in Miami, and this is Miami, have houses that have insurance. They have to have insurance because they're all bought by using loans, and you cannot get the loans if you don't have insurance. And they have insurance for 20 years, and every year the guys call them and say like, your insurance is up, you need to renew it, everything the same year, you same things, same terms, same price, you said, yeah, sure, let's just move on. And that works for like 20 years. But 5 years ago, you bought a solar panel because electricity cheaper, reduce the bill. What's going to happen in many of those places is there's going to be a hurricane, especially in Miami, and just going to trash a lot of those things. People call for insurance, say, okay, I have a damage at the roof, yeah, sure, what it is, solar panel, you're not insured, because 20 years ago, you were not insured. And now you have disappointed customer and a lot of money also. So what the system is doing is actually cross-checking which houses got the solar panels, checking the insurance policy, seeing is it there or not, and just call them people. And this is where you have this conversion and where you sell, and you actually make a lot of money. For insurance company, not that much for Sana, but it's another thing. So it's really from the point of view, like academical talk, it's like 5 years too late maybe for this, or 3 or whatever. But in a business setting, this is like the way how to actually use the deep learning in a business setting in a good way. You probably heard that by now, data is probably the most crucial part of every project. There are a couple of models. They work quite well. In the business settings, you're basically applying what other people developed for you. But what's really important is how you get the data and what is your data strategy. For those that you don't know much, this is actually what is explained everything. Deep neural networks need a lot of data to be better than what was used before. In most industries, most systems, you have something done before, either traditional machine learning or smaller neural networks. At the point where you have enough data, deep neural networks become really good. And this is where you have to get things. Like Ron was saying, doing pro bono projects. The easiest way is to get data. Doing the simulator, I will tell you this later on. One trend that we see more and more, and basically we're not really doing any projects anymore without a team that has domain expertise. So you have a team of AI experts, they cannot solve anything by themselves. You need a team expert, domain expert. In this case of the satellite, you need somebody who worked in the European Space Agency, otherwise you're gonna get lost with satellites. You don't know that thing. Trust me, I don't have a clue what's it. But if you have a domain expertise, you have AI expertise, you can connect with them. This is especially important if you work on a project in healthcare. We did one with the ACGs, automatic diagnostics. We would do everything completely wrong without having a hospital on the side. So the domain expertise, don't even go. If you cannot find a member of the team that really knows the domain perfectly, don't even go in that vertical. Don't go in the bank if you don't have a banker. Don't go in the hospital if you don't have a doctor. Don't go in insurance if you don't have somebody who is underwritten. They're just going to kill you, for sure. Another good thing is how to get data. Again, do pro bono. In this project, we actually gave service access to the center that provides us with the data. You have to get it somewhere, and you're going to have to pay it somehow, usually with your knowledge. Very important thing, and what I found out is you have to find a niche, and everybody says it, but the niche is something that's usually very non-obvious, because it's not obvious, because if it's obvious, it's not niche anymore. So I'm going to show you one thing that we're also doing with the Seek and Fit, one agency that has domain knowledge, has the data, it's automatic bidding in online advertising. For Facebook, for Google. And if you think about it, the first reaction of everybody is like, isn't Google reinventing themselves around machine learning and AI? Isn't Facebook just doing like the most awesome AI research in the world? Of course they do. Why they're not building this? Like, I'm crazy. Well, because the system has to have ability to move budget from Google to Facebook or Facebook to Google, depending on what is performing better. And actually they're not doing it, because they cannot. And once you find out that, you actually have the whole of feel to build a system, which we did. It actually is outperforming humans for doing the bidding on the campaigns for about 20%, using very, very weird strategies. One thing that we found out, how do we get data for this? Because you need like massive amount of data. And how do you get like 100,000 campaigns? We don't have that big databases. I actually wrote a simulator and just confirm it on the real campaigns. So again, you can read on the Wikipedia and nowhere else how the Google and Facebook works and how the bidding works, and you can just build a simulator for it. You can actually simulate how people are bidding, and you can actually train it all with them, and then just transfer it to the real world. Data generation. So what I wanted to do, like 5 steps to happiness, because everybody likes that, really to summarize what do you need to do to have like successful machine learning AI project today. One, deep learning is pretty much the standard right now, but don't reinvent anything. There are pretty much good algorithms model for everything that you're gonna need. Data strategy, you need to find out something. Either working for Bruno or writing simulators, you need to have some good strategy for getting the data. Extremely important is finding something that is of high business value, like Ram was saying. Don't try to model the hardware that's going to go out of the commission in like 1 month. Because you need to find, and for that thing, you need domain expertise. Without the domain expertise, there's nothing on it. And finding a niche. And finding a niche, when I said you like really try to avoid everything that everybody else is doing. Just do something completely different. Even if it means like trying to do something that you think that Google or Facebook should be doing. Because they're not. I actually checked all the competition. Actually, there are like 4 companies in the whole world actually doing exactly the same thing, which is nothing compared with the size of the market. All those projects, actually, we are looking for people to work with. And these companies are looking for the teams in Croatia, so ping me on mail, Twitter, LinkedIn, and we can discuss. Okay, thank you.
Are there any questions for Mr. Runje about his presentation?
Yes.
Yeah. Behind you.
Yes, I'm a student from medicine here in Zagreb, and we are doing deep learning with recognizing dog against some parasites, and would you be interested in that? I use single shot multi-box detector with PyTorch and the resonate 34, and I got validation loss of 2.24.
Okay.
So, and we are starting on the veterinary faculty with deep learning.
Yeah, I mean, this is like to be more technical, we should really take it offline. So what I usually say, like when I really do evaluation, there are a lot of inputs coming in right now. The AI is really, really hot, and like every day somebody calls you with a different idea, and that's good. So what we always really do is really go through these steps to really make sure that we have everything. So in case like your question, my first question will be, okay, you have some deep learning model, you reuse something, this is good, why, okay, we can discuss. What is your data strategy? How are you going to get the data? Usually...
I already have the data.
Okay.
I mean, I'm a student of veterinary medicine.
Okay.
Okay. I am a domain expert.
Okay.
And we already labeled 6,000 images with 5 species. So
okay, so you have really good cases, as far as I can tell. So we can, like, we should take it offline and discuss. Thanks.
Thank you. Any more questions?
Sorry.
What was the reaction of the homeowners who did own the solar panels when the agent from the insurance called them and said, look, I know that you have
It's the US. They call it for much worse things. It's like there's no data privacy in the US. Nobody cares. It's not Europe. Nobody cares. They're like, oh, thank you. Like, it's really good that you're thinking about my problem, which probably should be a reaction of everybody. Like,
Not sure.
it's not. It's not like it's you're their client, and they know that you are exposed to something that should notify you about. And I think in EU we're like way too paranoid with privacy. It's like getting ridiculous. Really, it's getting ridiculous. And it's not good for anyone. It's not good for society. For society, it's good if you have insurance company, not random insurance company, your insurance company saying you, oh look, we noticed that you do have insurance for your house, and you have 30,000 worth of solar panels on a roof, and there's a hurricane coming like 5 times a year. Maybe you should insure them. Just a suggestion. And normal people should say, like, this is a good customer service. In Europe, they say, like, oh God, they called me. Yeah. Not, I don't know.
My question is, how come you know that I have solar panels on my roof?
From satellite, you can see them.
Okay, fine, that's an answer.
Yeah, sorry, I didn't get it. I misunderstood the question, sorry.
But is it a privacy problem with scanning houses from the satellite?
No,
It's public.
it's like you can see it. Like, I don't know, grow higher trees or whatever, but then they wouldn't work. So, like, yeah, I mean, those images do exist. They're really high resolution. It's not just visual spectrum. You have like 8 layers. You do infrared. You do thermal imaging. So you have much richer data set than what you could just see like from the above, because they go through the clouds. It's industrial strength. So in this case, really, technical part was straightforward. The brilliant part was finding the use case, because it's high value. Because there's 30,000 on your roof which is exposed and not insured. This is a very good case for insurance company. Sorry.
So your 5 steps of happiness, I think they make lots of sense. There are lots of startups around the world
Yes, exactly.
who should follow these 5 numbers. But I'm curious again, it's about your own company. If you can tell us a little more about your own levels of happiness, how big you are, how old you are.
Okay, so
you want to grow bigger and bigger and something like that.
yes, so my personal role in those startups is I'm either a co-founder or have some share or build a team for them or educate. So I work in multiple verticals. Actually, the most of the work I do in financial business, but I can't talk about that. So it's either maybe well paid in money or in shares if it's a startup. I do from education to really solving the problems, building the teams. With different companies, I have different kind of setups. And I work through the multiple verticals and multiple companies. And some of them are more, some of them are less mature. Sorry.
Just one comment on domain expertise. I think it's crucial. I think it's important, but with one but. On the main side, it has to be somebody who is capable of thinking out of the box. It is very important from the domain side having somebody who is capable to think in terms of what can be achieved. Having somebody who is staying on the same ground can either drone the project with less success. I'm telling you that from the experience on the domain side. Just having you a food for thought, nothing else.
Yeah, so it's a lot of it's like with so let's say you have AI as like new toolkit, and there are a lot of success stories because the toolkit is good, the tool is good, and whenever you use it somewhere, it's better than what used to be. It's not your fault. It's just because the tool is so good. But everybody knows that the tool is good, and everybody has the same tool. The winning strategy is around other stuff, about like social engineering very often, about how to actually find out what the problems are, One, as Ram was saying, they're often doing things pro bono. What I often do, I do a lot of educations in a focused education in one vertical until I found out their problems. And when I find out what are their problems, then I can solve them. But for me, sometimes education is even more education for me than I teach people machine learning, AI, and everything, but then I learn all their problems. And learning their problems gives me perspective and approach how to do it. And there are many strategies, but you have to find some. Just like going from like 2 years of trying to use a new toolkit for business, solving the real business problem, not academia. Just applying whatever exists today and taking it from academia to the business. Say, okay, this is what we learn, and this is what the difficult part is. The difficult part is not to write code in Keras or TensorFlow, whatever. I mean, we are engineers, we know how to do that. The difficult part is really to find the real problems, real data sets, connect all those disconnecting dots. And the tool, everybody has the same tool. Everybody knows TensorFlow and everything. I mean, not everybody, but more and more people. It's not long-term advantage. Understanding how the process works for executing and selecting and initiating project is actually the crucial thing. You need to learn fast. Not fail fast, I would say like be successful fast, because you need success stories to get better deals, better projects, not failures. It's good to fail fast in the sense that you will not have to fail like after a long time, but actually what is building the business is success, not failures. And you have to find some structural way, and this is, I think, what I'm doing for myself. This is the structural way when I think about projects or industry and verticals, how to approach them. I will not just knock down the door and say, like, I have like some beautiful toolkit and amazing technology that is solving the hunger in the world. Give me some problems, because you will not get anything out of that meeting. You have to approach it in a different way. Through domain expertise, education, pro bono projects, different stuff.
Okay, thank you, Mr. Runia, so much. One more applause for him. Thank you.